Hello, good morning, good afternoon, good evening, and yeah, thank you for joining to the Full Stack GraphQL Book Club, Chapter 3. Hi, Will. How's it going?
Good. Good to see everyone. Thanks for joining today. I was just jamming out to that intro music. It's very, very catchy.
It is very catchy. Yeah, I like it a lot. It's a kind of long time running now. But the aura, the music is quite really. It's getting it's when this is playing, it's focus time.
It reminds me of the intro song to the morning edition show on NPR, and which is like National Public Radio in the U.S. They have a very like a big orchestra that you rarely hear the full version of it though. But yeah, it's good.
Yeah.
Good intro music. I like it.
Yeah, totally. So yeah, this is chapter 3 of the Full Stack GraphQL book. So if you have not read the book, downloaded the book, looked at the book, don't worry. We are only at chapter 3. I think you can still catch up. You can follow along as you like today, and then afterwards check out the book. Obviously, we will go through the book chapter by chapter. So this is the idea. We will, Will is going over the respective parts of the book, and particularly we focus on the exercises and go through them. So you can, if you do them afterwards yourselves or have done them already and struggling with something, we go through them. So if you have any questions, anything particular you like to know about chapter 3 or about the book in general, then obviously use the chat. So we can have a look out for that. We had a little. I think I mentioned this last time when we wrapped up. We had a little GraphQL week going on this week. So we had a live stream yesterday with Alex, another Alex from 3 Edges, and they talked about some footfalls or steps you need to take care of in terms of GraphQL and how to work it. So I think a couple of these things resonated with what you already said last time when we covered chapter 2. So that was interesting, and they have like this API connection with GraphQL, and so you can set up is particularly role and access management, read and write allowances to users, and to set up this in a very easy way. So that was yesterday. Let me post a link in chat if you are interested in that recording. And next week is GraphQL Galaxy, which is an online virtual event. Neo4j is also sponsoring. We have a talk. Thomas, our colleague Thomas, is speaking at the program, and Will, you are giving two workshops.
Exactly. Yeah, Thomas is doing a talk on GraphQL subscriptions with Neo4j, which is super cool. And I'm doing one workshop on the Neo4j GraphQL library and Neo4j Aura. So building GraphQL APIs that way. And then a second workshop, which is once you've built your GraphQL API with Neo4j and Aura, how do you leverage that in an iOS app, so mobile apps. So we're looking at using the Apollo client for iOS library, which recently had a momentous 1.0 release, so lots of interesting new features there. We build a fairly simple news reader application. So we pull in news from around the world. How do we show news close to us, the latest news in an iOS app?
Cool. So yeah, that's what's going on around GraphQL in particular, and yeah, I think we are almost ready to go. I'd like to ask one question to you, Will, before maybe we talk about the actual topic. And the first episode, when we talked about how you came to write the book and how you developed the book a little bit, you mentioned that you wrote the book actually on an iPad. or
Most of it. Yeah.
most of it on the iPad. So I was wondering when I heard that, and we didn't have the time to elaborate on this last time, but I was wondering how how was writing on an iPad.
I've been meaning to write a blog post that describes this experience, because I think it's something that a lot of folks are interested in. Because I think the iPad is a really great format for focus, which you need to do when you're writing a book, because you sort of need to be immersed in writing and not have distractions of another browser tab to check your Twitter or whatever. And just the form factor of an iPad is, I think, very good for that. And also at the time I was traveling a lot, and so it's very very portable and easy to take around. So I enjoyed it. I used mostly this app called Working Copy, which is a Git client. So I pointed that at the GitHub repo for the book. And so anytime I had updates, I just pushed those directly to GitHub from the iPad. And then I had a little process that would build a web version of the book. So Manning, the publisher, they give you the option of writing the book in Word templates, which I didn't want to do, or writing in ASCII doc. If you're familiar with ASCII doc, it's kind of like Markdown. So it's a markup language for text. It's what a lot of projects use for writing documentations, like the Neo4j documentation is all written in ASCII doc. And so I wrote the book in this ASCII doc, and then I would just sort of have a automated process. I think I was using Netlify to build both a PDF and an HTML version of the book, and then publish that somewhere so I could see it live. And yeah, it was good. I wrote a lot of the book in lots of different places as I was traveling around.
Did you use a keyboard with that, or did you actually type on the touch screen?
Yeah, definitely had to have a keyboard. There's like some sort of keyboard folio. I think it's called the Magic keyboard, and everything is Magic something and Apple's stuff. So that thing, which is, it's comfortable enough. It's fine. Yeah. I think the funnest experience, I was out driving around somewhere in the woods, and we found a nice spot to sit down and have a picnic by a creek, and so I needed to make some book updates, and so I was working on it, and a moose, actually two moose, walked by the creek and kind of startled me while I was working on it.
They probably were startled as well. Who's sitting here?
Exactly. Yeah. But yeah, I want to write up a blog post that kind of summarizes the different tools, because I use some different tools.
That would be interesting, I think. Yes. Yeah.
There are some challenges, right? So things like how do I work on the code snippets, writing the book, how do I do diagrams, that sort of thing was a bit of a learning experience. And not 100% of the book was written on the iPad, but I would say the vast majority was. So yeah, look for a blog post sometime, kind of just explaining what that process was like. I think I have the moose picture somewhere, so I'll try. Oh
yeah, that needs to go into that blog post. Yeah. All right. I think that's good. So I'm putting up your screen. Let me get this out of the way, and then chapter 3.
Cool. So first of all, like Alex mentioned, you can download this book for free from the Neo4j site. I think Alex dropped a link to that in the chat. So definitely, if you haven't grabbed a copy of the book, Neo4j was nice enough to sponsor that. So it's free to download. Just fill out this form and you get the PDF version. And so that's what we are working through. So on the left here, I have the PDF version of the book that you will get if you fill out that form. We are on chapter 3. So this page, this is the kind of the landing page for, I guess, the recordings of this book club live stream that we've done so far. So if you need to catch up, chapters 1 and 2 recordings are here. Chapter 3 this is what we're doing today. And then a look ahead, just mostly to remind myself what the schedule is for this. So today is December 1st, we're doing chapter 3. Alex mentioned GraphQL Galaxy is coming up next week. So we're taking a week off from the live stream, and then back with chapter 4 on the 15th. And then I can take a couple of weeks off for the winter holidays, and then back in January for the rest. So still plenty of time to catch up and follow along if you're interested. Oh, and then also I want to drop a link to the GraphQL Galaxy conference that Alex mentioned. There's lots of good stuff here. We were at GraphQL Galaxy. It's an online conference. We were there last year as well, which I thought was really fun.
Yep.
Here's Thomas's talk all about using subscriptions with Neo4j and the Neo4j GraphQL library. This is a somewhat new feature. It's still in beta, but I think most things have been finalized for the subscription API for the Neo4j GraphQL library. So I think that will be moved out of beta soon. I'm sure Thomas will talk about that. And then the workshops.
Cool. I think we had a couple of questions about the subscriptions feature here in chat, I think during nodes as well. So it's good to see.
Totally, yeah. It's something that that's a really cool feature, kind of the publish subscribe model, and something that is trickier to implement. There are lots of moving pieces there, especially if you have multiple GraphQL server instances. So if you've horizontally scaled your API, that's where you need to make sure you're capturing all the correct events to be published. So anyway, Thomas will talk all about that. And then the workshops that we mentioned, I'm doing this one on Neo4j GraphQL library with Neo4j Aura, which will go over similar to what's covered in chapter 4. Well, chapter 4 onward in the book, I guess, is where we start using the Neo4j GraphQL library. So far, we've been looking at creating GraphQL APIs mostly by hand, bespoke, perhaps, is the way to think of that. And this shows how you can get rid of a lot of the boilerplate code and get some advanced features to build that API layer on top of Neo4j. And then here's the iOS Swift UI workshop that I mentioned. So those are both next week.
Very cool.
Cool.
And because it's online, everybody can obviously go and register for it. So if you're interested, yeah, check it out.
Exactly. Cool. So that brings us to the book. So this week we are covering chapter 3, which is all about Neo4j. Just a quick refresh. So chapter 1 introduced the different components, the different pieces of a full stack GraphQL application. Make this a bit bigger. There we go. So we're using Neo4j as the database. We're using React on the front end, which we'll get to starting in chapter 5. And then our API layer is a Node.js, JavaScript, GraphQL server application using Apollo server and the Neo4j GraphQL library. So that chapter 1 just kind of introduced the different pieces. Chapter 2, we started looking at I guess what I call in the book is the naive approach of building a GraphQL API. So this is defining your GraphQL type definitions and then writing resolver functions that define how to go out to the data layer to fetch data based on the type definitions you've written. So we did that in chapter 2 last time, and we saw some of the issues that come up around performance issues. We end up making multiple requests to our data layer for one GraphQL request, which is not great for performance reasons. And then there's a lot of kind of boilerplate data fetching code that we have to write, which can be a bit time consuming. So we did that, was that last week? Chapter 2. Now we are on to chapter 3, which is called Graphs in the Database, and we are talking all about Neo4j. So we won't really touch much on GraphQL in this chapter because we want to cover what is Neo4j, what is a graph database, what is the property graph model. We'll take a look at Cypher and some of the Neo4j tooling that we use.
Very cool. So I guess, I mean, if you are coming from the Neo4j ecosystem, this is probably more of a repetition than anything new, but still, it's probably worth you to stick around. Maybe you good to hear again, and if you obviously come from pure GraphQL world, it's a good intro session.
Totally, exactly. So the first thing that we talk about in the book is what is a graph database? What do we mean when we say graph database? So Neo4j is an open source graph database, and fundamentally, I guess from a user's perspective, the first thing you notice is that the data model is a graph. So other databases, relational databases, use tables as the data model, and other types of databases are out there, such as document databases, like Mongo, where you use a document, like a JSON document is the data model that you work with. In a graph database like Neo4j, the data model you work with is a graph. So nodes are the entities, relationships connect them. We store arbitrary key value pair properties, both on nodes and relationships. So if we compare that graph model, kind of how we think about working with data in a relational database or a document database, this diagram, I think, does an okay job, hopefully getting at that concept. So here we have some person nodes, people have hobbies. We can see in the graph, we have—
I think you want to zoom in a little bit on this one. This is a bit small. Yeah, that's better. Yeah. Or yeah, that's even better.
There we go.
Yeah.
Cool. So you can see in the graph how we model that is very similar to how we think about this, right? So if someone were to give you a dry erase marker, send you to a whiteboard and say, give me a diagram of people and the hobbies that they have, well, you would kind of go through this data modeling approach and think of, okay, well, what are the things, what are the entities? Well, okay, I'm probably gonna draw some circles on the whiteboard to represent those. So I've got hobby golf, I've got people, Bob and Carla, and then, well, people are connected to a hobby, so you're going to draw an arrow connecting them, and that's a graph. That's how intuitively we think about data connections of lots of different domains. Emil is the CEO of Neo4j. He likes to say, well, if you go to Google Image and search domain model, you see graphs, and the point there is that graphs apply to most domains, and that's how we intuitively think of data. If you compare that to how we would model this in a relational database, well, we're going to create a person table, and that's going to enumerate all of the people that we're working with, and we're going to have a primary key that represents the ID value of that person as a row in the table. We're going to do the same for hobbies, but then how do we connect the people to the hobbies with a table? That's where we introduce this concept of join tables. And that's where I think the intuitiveness starts to break down in relational databases. And then there's a whole sort of science to normalization and data modeling in a relational database that addresses things like performance aspects, and it's, I think, very separated from how we intuitively think about data, I guess is the point. If you think of this join table, well, we have to basically refer to the people in the hobby that we want to connect by their IDs, by their primary keys. So then those become, we're called foreign keys in the join table. So Anyway, that's how we work with that in a relational database. So if you're familiar with working with relational databases, that makes a lot of sense. But if you're sort of new to it, I think it doesn't do a great job of mapping how we think about data to how we work with data. And then if we look at how we would treat the same data set in a document database, there's a few different ways to do this. One is to just sort of embed all of the information in the document. So we would, in this case, if we were trying to represent that Bob and Carla are friends, well, we have a couple of ways of doing this. We could embed all of Carla's information in the Bob document. So that way you just have to look up Bob's document and then you have all of the data you're interested in that's directly connected to Bob. The problem with that is you end up duplicating a lot of data.
Yeah.
And then if you have to do an update to, let's say, Carla's address changes or something like that, then you need to figure out like, well, now I have to find every single document that has this information. Or you can do what we've done here, which is similar to how we do things in relational databases. We have kind of a pointer to the ID for friends. So friends becomes an array of user IDs that we're friends with, which you can then go look up in the database. The problem with that is that that sort of join operation is not really built in to document databases the same way that sort of joins are available in SQL. So that you can do it. It becomes a little awkward sometimes. But anyway, so those I think are kind of the three main database models that you see out there currently for working with data, and we're taking the graph approach. Now, this book is about GraphQL, and like ultimately we are building GraphQL API. So the question is, what are the benefits, or why would we use a graph database with GraphQL? And I think there's a couple of interesting points to consider here. One, we talked about this like intuitiveness aspect. And when we're talking about the data model that we use in a graph database compared to the data model of a GraphQL API, well, they're both graphs, right? Like in chapter 2, where we were looking at our business requirements for the application that we're building throughout the book, which is a business reviews application. So users review businesses are in a category, this sort of thing. The way that we sort of approach creating our GraphQL type definitions is we go through almost the same graph data modeling process that we would go through if we were working with just a graph database, which is you sort of go to a whiteboard, think what are the entities, how are they connected, you draw out a graph, and that's almost the exact same data model that you use in property graph database like Neo4j as you do in GraphQL. So you don't then have this mapping and translation layer when you're going from querying the GraphQL API to querying your database. So that's a huge conceptual win there that simplifies building your GraphQL API backed by a graph database. The other benefit to consider is performance. So graph databases are optimized for working with graphs, just like relational databases are optimized for working with tables. So in a graph, traversing this graph, so starting from Carla to find her friends and the hobbies of her friends, we're traversing from one node to another, sort of following these relationships. And graph databases are optimized for that traversal. So that traversal, this concept called index-free adjacency, which means that we're basically just following a pointer is one way to think about that, which computers are really good at, following pointers, without having to use an index, which is then the performance of an index lookup is dependent on the overall size of the data. So in a graph database, because we're not using an index for these traversals, we have really efficient ways of traversing the graph from a well-defined starting point. The performance of that traversal is not dependent on the overall size of the data. If we compare that to how we would do this in a relational database, well, going from a person to their friends to a hobby, we have to do a join operation. So that's looking at where two sets overlap, two tables overlap. And then if we have lots and lots of rows in our tables, the performance of that join is dependent on the overall number of rows in the tables, and that starts to slow down. So what does this have to do with GraphQL? Well, when we were looking at our GraphQL queries and we see these sort of nested selection sets. So in the example from last week where we were looking at, say, users who wrote a review of a business in a category, that's essentially like 3 or 4 join operations or a traversal in the graph. So GraphQL lends itself to these like very nested queries that in a relational database end up being lots of joins in a single query, which can be quite slow. But graph databases are optimized for those sorts of graph traversals. So the second benefit that you think of when you're using a graph database to back a GraphQL API is that performance consideration. Graph databases are optimized for traversing the graph, which is what a GraphQL query is describing, a traversal through the data graph. Cool. So that's the graph database concept. We talk a little bit in the book in the next couple of sections about more specifics on the property graph model, what exactly that means. We talk about creating constraints and indexes, these sorts of things. But what I want to do is jump ahead a little bit and talk about some of the tooling that we use with Neo4j.
Mm-hmm.
So in the book, we talk about Neo4j Desktop. Desktop is, if you go to download Neo4j, that's kind of the default tool that you get. So desktop is, I think of it as like mission control for working with Neo4j locally on my machine. So I can create projects, I can have multiple databases. In each project, I can use graph apps, so things like Neo4j Browser or Neo4j Bloom, or some of the third-party graph apps that are out there for working with my data. And then we use Neo4j Browser as kind of like a query workbench for interacting with Neo4j. So we have a sort of Cypher editor. So Cypher is query language that we use for working with Neo4j, which we'll talk about in a minute here. And in Neo4j Browser, we basically write Cypher commands, and then we get these visualizations, or you can also see tabular results of the data that we've returned from a Cypher query. So useful for development and testing.
So for the Neo4j pros, let's say, what's the preferred way to give this to try it out? Is browser or desktop? Sorry, is desktop the best way? Or if you have an Aura instance, for example, is this also, is there any difference, or would you say what's better to start with GraphQL and Neo4j?
Yeah, so so browser is available in desktop, which if you want Neo4j downloaded on your laptop, that's the best way to do that. Browser is also available in Neo4j Aura, and when we go through the exercises, I think let's use Aura. We'll take a look at that just to see something different. Aura is great. There's a free tier, so we don't even need to put in a credit card. There's lots of sample data sets to work with. And then Sandbox is another option. Sandbox these days is, I think, more useful if we're interested in some of the data science aspects of Neo4j. So if I'm interested in graph data science, graph algorithms, that sort of thing, Sandbox has more more of the educational and trial content there. So that's a good place to start. But browser, yeah, browser is also available if I'm using Docker with Neo4j. So basically, however I've set up Neo4j, Neo4j browser is there as kind of the first tool that we reach for, I think, typically.
Yeah, cool.
And of course, with Neo4j browser, we are using Cypher. So Cypher is the database query language that we use with Neo4j. I like to think of it, if you're familiar with SQL, Cypher is like SQL, but for graphs. And the core part of Cypher is this idea of graph pattern matching. So we draw these sort of ASCII art representations of the graph pattern that we're looking for, and then the database figures out how to find that, how to work with that graph pattern, which is really fun to work with. So in the book, we go through some of the basic Cypher commands. I won't go through those now because we'll see some of those in the exercises when we work through that. The Cypher ref card, let's find that. Oh, which is now the Cypher cheat sheet, rather. This is a really good reference for just seeing all of the different things we can do with Cypher. So I use this pretty frequently just to look up syntax for various Cypher commands and that sort of thing. So that's a good resource to have open. Cool, and then we talk a little bit about using the client drivers, which we'll take a look at when we go through the exercises. And then the exercises for chapter 3.
Just maybe quickly for the on the cheat sheet. So I mean, if I find it's very useful with the cheat sheet, but then you can also, if you need more explanation and more detail on some of these, you can, the documentation on Neo4j. So you go to neo4j.com/docs, you will find probably each and every one of these explained with more detail, with some code examples, with some, almost like a tutorial, like where you get usage inside. So if you're wondering, is this doing this what I want to do, then read on the docs for more explanation.
Totally, yeah, exactly. Cool. So the exercises for chapter 3 are all based on the data set we're going to work with for the rest of the book. But before we jump into the exercises, maybe we should take a look if there are any questions that folks have. Who's following along so far in the book? Are you running into issues? Like, I'd love to hear what folks think so far.
Yeah, type it in the chat. So far, I see no question. I see only from Václav. He likes a special offer with a signed book. So I don't know if this is something you want to offer, or if Manning is offering. I don't know if they are offering signed book copies, hard print copies of the book. Definitely something to look at. I don't know, Will, what's your view on that?
Yeah, that's a good question. We should do something around that. I always prefer to have the printed version of a book. Well, it depends on the book. It's nice. I like highlighting and writing in the margins. I don't know why that seems to be the best way for me to retain something that I'm learning. But yeah, this is I have a copy right here. This is a actual full book, not just an ebook. There's lots of fun, like diagrams and things like that throughout the book. Yeah, we should do some sort of fun signed book promotion. I know we have some books that we give out sometimes at conferences and things like that. But yeah, let's think about something to do online. And find one in your Christmas stocking. I know that
Yes.
that's what all of my friends and family are getting from me this year. A signed copy of the book.
Yeah, I mean the time would be good. We can at least maybe we do a special quiz or something on. I mean it's short notice now, 15th in the next episode. Let's think about it, and then maybe we give away one or two signed books.
I see a message from Peter talking about the diagram I was showing earlier. Let's look at that one. This one. Doesn't it show that Bob and Carla are friends with themselves? Yeah, it does. That's a good catch there. So the array of IDs here. So if we look at the friends table for our join table.
It's again a very small. Will, can you?
Oh yeah. Sorry. I have this giant monitor here in front of me, so everything looks so big.
Yeah, that's okay.
Yeah, exactly. So if you look at the join table, so this is saying that person 1 is friends with person 2. So Bob is friends with Carla, and person 2 is friends with person 1. So representing that the other way. But then yeah, we made a mistake in the document version saying that Bob, who's ID 1, is friends with ID 1. Yeah, that should be 2 here, and this should be 1 here. I think that's in, or will be in the errata for the book, so we'll catch that for the next printing. So yeah, good catch there. That is kind of confusing. Cool. Let's move on to our exercises, and we'll see if we can get through these in the time that we have remaining. So the exercises say to use desktop and Neo4j browser and desktop, but I think we can use Aura instead. So I have Aura open in a tab here. So Aura is Neo4j's managed cloud service, so database as a service. And what's really nice about Aura is that once we sign in, so let's see, I'll sign in with my Google account here. I think this one doesn't have any active Aura instances. Yeah, there we go. So what's nice about Aura is we have Aura free tier instances. If I click new instance, these are going to be free tier options, which means that they stick around. So once I spin one up, it's there, private to me. I don't have to put in a credit card or anything. But unlike Neo4j Sandbox, which goes away after 3 days, right? We can extend it up to a week, but the Aura free tier instances, those stick around. So I can build an application backed by an Aura free tier instance, and that database is not going to go away. So it's good for like hobby tier projects, and also for experimenting and learning. So these options include data. So they have data and kind of a guide to walk us through various things. But we're going to start with just an empty instance, since we're going to load our own data here. And here's our generated password. I'm going to download the credentials, just copy them as well. Make sure we have those. So this is nice. When I download the credentials, it downloads a .env file. So that's a way of declaring environment variables that I could then load in an application to connect to my Neo4j instance. They'll say, yep, we've saved the password. Great. Let's continue. And then this will take a few moments to spin up here. So while we're waiting for that to load, let's take a look at some of the example code that we can see here on Aura. So in this Aura Connect tab, we have basically example code for connecting to Aura from the various Neo4j drivers. So Python, JavaScript are here. shows us how to load a simple sample data set and then query that. But there's also a GraphQL example here. And this is, we haven't exactly used the Neo4j GraphQL library yet. We will starting in chapter 4, but this is kind of the very quick way of spinning up a GraphQL API using the Neo4j GraphQL library, where we define some type definitions. We pass those type definitions to the Neo4j GraphQL library, and then we basically generate a GraphQL executable schema object is what it's called, but that's the combination of type definitions and resolvers that have the logic for fetching data from the data layer. But what we notice here is that we didn't write any resolvers. So last week we spent a bunch of time writing resolver functions. We had some mock data in a JavaScript object, and we were writing things to filter our business by some string and things like that. But we don't have to write those resolver functions with the Neo4j GraphQL library, because all of that logic is generated for us. So you can see there's not much code that we have to write to get a GraphQL API up and running. Anyway, so that's nice. If you're interested in using other languages to connect to your Aura instance, you can find that those examples here in the Connect tab. Okay, our instance is up and running. That's great. So we were talking before about Neo4j browser. We've mentioned things like Neo4j Bloom, and in Aura, there's now a new way of organizing those tools. So instead of browser Bloom, instead you see explore, query, and import. And so these are part of what's called Neo4j Workspace, which is a newer way of sort of organizing developer tooling for working with Neo4j. So if you're familiar with Bloom, that's this Explore tab, and Browser is the Query tab.
Yeah, and you can toggle between the views, so Workspace and the regular one on the top of your browser window.
Totally. Although I think I'm in the, I'm still in the classic view, aren't I?
Yeah, but you can exactly here, if you click on your, you can switch between the two.
Exactly, right. The verbiage remains the same.
Yep.
Okay, so I just pasted in my password there. Okay, don't say my password. Okay, cool, right. So it takes us first to import. This is, so import is really cool. This is the, gives you the ability to visually import data from CSV by building up your graph data model and then clicking a button, and then that handles the data import. We're going to load data a slightly different way. So what we're going to do is, in the exercises, it says to load a browser guide with embedded Cypher queries. Let's stick to the browser, Neo4j browser view. So this will, this will be what you'll see exactly if you're following along in the book here. So we'll do a : play grand stack, and this will load this, what's called a browser guide. And so a browser guide allows us to basically load some content that can be text, queries, images. It's useful for a lot of the training material that you'll see in some of the things like Neo4j Sandbox, the example data sets, this kind of thing. So this one's very simple though. It's just one embedded Cypher query, which I'm going to run.
It's more, it's like you can understand it as much as a a step-by-step tutorial or a step-by-step process of getting data in your database, or helping you, explaining you some queries, and showing you how it works. So you can, it's good for learning, I think.
Totally, for sure, for sure. And this is the query that we're executing. You can see there, I get a warning here because the query plan has what's called the eager operator, which if your data set is large, it's just kind of a warning that you may want to rewrite it in a different way to be a bit more performant, or break it up into multiple statements. It's okay because for this one, because our data set is quite small. But what we're doing is we're loading a CSV file from this location, and then we are creating business nodes. We are creating user nodes, review nodes. We're creating relationships between them, and then we're creating some categories connected to the businesses. And when we run this, we can see that, hey, I've created 36 nodes, set some properties, created some relationships.
Zoom in a little bit.
Yes.
Yeah, thank you.
So the first exercise is run the command call db.schema.visualization to inspect the data model. So let's do this. So db.schema.visualization, this is a built-in procedure that basically will inspect the data we have in the database and give us a graph view of that data model. So we can see we have users wrote a review reviews a business, and the business is in a certain category. So that's the data we're working with. We saw that just by inspecting the Cypher query. So when it's asking us what are the node labels that we're using, well, the node label, so a label is a way of grouping nodes, similar to conceptually like a table from a relational database is, I guess, a way to think of it. So the labels, or the grouping, the type of nodes that we have are user, review, business, and category. And it's asking about what are the relationship types? Well, the relationship types, so every relationship has a single type and direction that describes the relationship, describes what the connection is between two nodes. And relationship types we have are wrote, connecting user and review, reviews, connecting review and business, and in category, connecting business and category. Cool, so that's number one. So the next question is, write a Cypher query to find all the users in the database. How many users are there, and what are their names? So to do this, we're going to use the match Cypher command, and then match, with match, we then define a pattern, so a graph pattern that we're looking for. And the simplest pattern is like this, 2 parentheses. So we said we draw this sort of ASCII art representation of our data in Cypher. So the 2 parentheses indicates a node, and we're looking specifically for user nodes. So when I start typing a colon, so a colon is just a way of indicating that I'm going to refer to the label of the node, or if I'm using it in a relationship pattern to refer to relationship type, but I'm in the node here, so I get the autocomplete for the various node labels that we have. We want users. So now this says find user nodes, but I need some way to refer to the user nodes. And so before the colon, I'm going to add a U. That U now becomes a variable that I can refer to through the rest of this Cypher statement. And then I need to do something with the nodes that I've matched on, the nodes that I've defined in this pattern. The simplest thing I can do is just return them. So let's run that. And okay, I get these sort of free-floating nodes in this graph visualization, and they're not connected to anything because I didn't return any relationships or any other types of nodes in my Cypher statements. That's why they're just 4 lone nodes here. I can click on them and then I can start to traverse out through the graph. But to answer the question here, so how many users are there? Well, instead of just returning the nodes, I can do things like aggregation. So here, let's count how many there are. And notice that if I'm returning tabular data, my result is a table instead of a graph because I'm not returning graph data here. I'm returning the result of this count aggregation function, which is just a number. And then similarly, I can also return just pieces of the graph pattern that I've matched on. So I don't have to return the nodes themselves. I can return just properties of the nodes. So here are the name properties. I can see the 4 names of the users in the database. Cool, so that's exercise 2. In the next few
interesting point to make is because Neo4j is a graph database, it doesn't mean it cannot handle tables. So you you can always output your data as a table. You can even maybe click on this little arrow top right and download this particular table as a CSV file. So you can always continue on working with your graph data in a tabular way if you prefer that, or if you like to export a snippet out of your data into that format.
Totally, and oftentimes the answer to my question is a table, has a tabular result, but the way that I get there is by traversing the graph oftentimes.
Yeah.
Yeah. Cool, so that was number 2. The next few exercises are going to have us creating more complex graph patterns, which is helpful to understand some of the power of Cypher. This example, I think, doesn't do a great job of showing some of the...
somewhere.
That's true. But I think this idea of graph pattern recognition, I think, is a really important feature of Cypher and really powerful. So it's cool to see more fancy examples, I guess. So the next one, find all the reviews written by the user Will. Okay, well, we can see we have a user with the name Will. And if we look at our graph schema visualization, we can see that we have users connected to a review through this rote relationship. So I know I want to traverse this rote relationship, but first I need to match just on the user Will. And there's a few ways to do this. I could add a explicit where predicate to say where u.name is Will, return u. And if we switch to the graph view, you can see, yep, here's that user Will. Equivalent syntax would be inside curly braces like that, and then I can remove the where predicate. I get the same result. So this is useful with inside the curly braces, is a bit more readable. I can only do things like exact comparisons here, but with a where, I have a lot more options for predicates. For strings, I can say like
exactly, yeah,
where u.name contains. So if I don't know, exactly, maybe I want everyone that has W.
If it's like a Will or William, you don't know how it's in the data, you can just say.
Yeah, exactly. So that's the first part, and then the next piece is to find reviews that this user wrote. So now I'm going to create a relationship part of my pattern here, say where this user wrote reviews. So now this pattern. So let's find the user will, traverse out along rote relationships to find reviews. And then instead of returning just this U node, I need to change this to return, either U and R, or what I like to do is just return everything that we've matched on. So here's the will node, here's 5 reviews, and you can see the properties. If I hover on these, I'm not seeing that in the caption. So if we click on review, then we have the option of choosing what we want for the caption. So we can do the text of the review, the date of the review. Let's just do the stars.
Mm-hmm.
Cool. So here's all the reviews that I've written, or this user will has written rather. And the next question is, what is the average rating given by
totally different
this user? That's right, a fictional. Yeah,
fictional
these are in no way my favorite businesses that I just looked around and made fake reviews for. So the question is, what's the average rating given by this user? So I have the stars for each review here. What I want to do is calculate the average. If we go to our cheat sheet, and if we look for the math functions, I'm sure we're going to find an average here somewhere. Is that, it's probably not, actually it's probably an aggregation function.
Could be, yeah.
Yeah, in aggregating functions. So it's an example I have are sum or average, min, and max. So where are we here? We can return the average of, and now we're going to want the rating. Is it rating? We'll see. R.rating property of review. It's not rating, so I get a nice little squiggle. I want stars. And so the average ends up being 4.2. Cool.
Mm-hmm.
Okay, number 4, find the business reviewed by the user well. What's the most common category? So now we need to, let's go back to just returning everything that we've matched on here. So here's this user, here's the reviews. I can do things like double click on these to traverse out to see what business they are, and then what category they are connected to, and so on. But I want to express that piece of the pattern now in this Cypher query. So I can continue to add on here to the pattern up here. So I can say review reviews the business, and now I return that. Now I get the businesses included as well. I can also create another match statement. And so now I want to go from the business to the category. It's just breaking it up into multiple lines kind of helps with readability a bit.
Mm-hmm.
So we don't just have one massive long pattern.
Yeah, particularly when you have connecting a couple of these together, then it might be a bit easier to read.
Totally. Okay, so those are the businesses and the categories, and we need to find the most common category. So is there a category that shows up frequently? And to do that, we can, well, one thing is we can look at this graph and I think start to see the categories. And I don't see any overlapping categories right away here, just from the graph view. So I think we know what the answer is going to be, but we can do something like this. First, let's return the name of the category. Okay, so here's all the different categories. And then what we're going to do is an implicit group by here. So anytime in Cypher that we are returning the result of an aggregating function along with some value, we end up doing an implicit group by that value. This is different from how we would do group bys in SQL, where we have to explicitly say group by this value. But that's that's sort of equivalently what we're doing here, simply because we're returning some value alongside an aggregating function, in this case, count. So what this is saying is, okay, find all the businesses that this user will reviewed, find out what categories those businesses are in, and then for each of those categories, count the number of paths back to will, which in this case ends up being the number of businesses or business and reviews. And because this is kind of a small data set, we end up with just one for each category. So there isn't a category that has more reviews than any other. So kind of a boring answer. But again, we knew that was going to be the case when we saw this graph view of that query, because we didn't have any sort of overlapping categories, these orange nodes here.
And I think this is a great example of what you showed earlier is, right? I mean, if you click on the table view, you can probably also look at it and deduct it from there if you look at it thoroughly, and but it's already with this small data set quite not really clear already what's going on here. And here in the graph view, you can make sense out of the data even without having to do much of a think. Whereas here, I don't know.
Totally, yeah. Like graphs are very visual and help us to rapidly convey information. Tables are not that visual. Yeah, totally. That's a good observation. Cool. So one more question here, which is, write a query to recommend businesses to this user will that he has not previously reviewed. So there's a few ways we could do this. I think, personalized recommendations, this is a practical example that comes up a lot when we're talking about graphs in Neo4j, because that sort of people who liked this also liked this thing. That's a very practical query that is fairly simple to express. So let's approach it that way. We have reviews here, so we could also do things like calculate cosine similarity and things like this. But I think the simplest version to start with is just to say who has reviewed businesses that this user will has also reviewed. What businesses has that other user, those other users that have similar tastes as user will, what other businesses have they reviewed that will has not? Those might be a good recommendation for this user.
Yep.
So we'll start with this piece of our query, which is find all the businesses that this user will reviewed. And then let's find other users that have reviewed those same businesses. So we'll just add on to our pattern here. So let's find reviews that review businesses that were written by, say, some other user. And then we'll return this U2. So we end up with 1. So there's one user that has reviewed other businesses that this user will has written. So now let's traverse out from the U2 user to find what businesses they've reviewed. So wrote review and then the reviews, and we'll call these the rec for the recommended businesses. So these are going to be the user recommendations. So these are businesses that users that have reviewed businesses that Will has reviewed, but this user may have already been to these businesses, may have already written reviews for those. In that case, that's not a very good recommendation. Like, here's something that you've already bought, is not a very good recommendation.
Yep.
So we need to filter those out. So we'll say where not exists, and then exists takes a graph pattern, and also we'll say where not exists, the user u. So u is this variable that's bound to this piece of our graph pattern, so the user will. So let's filter out any business nodes that have a connection to this user. So where this user wrote, get all of our arrows in there, wrote a review that reviews. In this case, we're going to use the rec variable. So that's referring to this, so our recommended businesses. And then return our recommendations. And if we run that, we get 1. So we filtered out the other 2 that the user Will had already been to, and we recommend this great ramen restaurant, Hanabi, in Burlingame as our personalized recommendation. So this is the business that we found that users with similar taste to Will, so users that have reviewed businesses that this user has reviewed, that this user has not written a review of, so potentially has not been to this business. So that would be a good recommendation.
We can even expand on this, and like we said before, we showed the average rating of user Will's review. So we could say, okay, only in this case it's just 1, so it doesn't make much sense, but only give me businesses that other users have favorably reviewed. So let's say any that had a rating of 4 or more, and then give this recommendation, because I don't think you want to recommend a user to go to a restaurant that got lots of 1-star reviews, let's say, to maybe give them a better time to say, okay, hey, you haven't been to this place and other people like this place.
Totally, yeah. There's a lot of ways we could go from here. These sort of recommendations I think of in 2 broad categories, which is collaborative filtering, where I'm using sort of the information from other users in the network, where I have either reviews or purchase history, or if I'm looking at like clickstream data, like sites that users have been to, this sort of thing. But collaborative filtering, where I'm using data from user interactions in the network. And then the other sort of broad category is content-based. And so for that, we have categories of business. So I could do things like, what are categories that this user Will frequently reviews? What are other businesses in those categories? If I wanted to go more advanced in the collaborative filtering aspect, like Alex is saying, we could look at just positive reviews. We could quantify this with similarity metrics that allow me to do things like find users with similar tastes. And for that, we would use something like cosine similarity or something like that. And those sorts of algorithms are built into the graph data science library. So we could do that that way. We could also go down the graph data science path of maybe creating clusters, finding communities of similar businesses to represent alternative recommendation. We could do do link prediction, feeding into a machine learning model with graph embeddings. Lots of interesting things we can do. Although I think on this data set, all of those would be bit of overkill, but
it's
they're
overkill for sure. But it's just, because this is more like an intro overview. I think maybe it's just you have an idea. This is just scratching a little bit the surface, but we can obviously go deeper. But it's not for this session here, maybe.
totally. And in both in Aura free tier and in Sandbox, there's a recommendations use case that does exactly that. So it's the movie lens database of movie ratings, and it shows how to do exactly some of the things we talked about with things like some of the similarity metrics using the GDS library. So that would, if we're interested in sort of learning more about recommendations, I think that would be a sort of the next step would be to fire up the recommendations or a free example set or on Sandbox for sure.
Yep.
Cool. Well, we made it through the exercises, just a little bit over time, so sorry about that. But that is chapter 3. It's just sort of a brief introduction to Neo4j, some of the Neo4j tooling with Neo4j browser, the Cypher query language, and then an introduction to the data set that we're going to use throughout the rest of the book. So we're building a full stack business reviews application. So we seeded that initially with some businesses, some users, some reviews, and so on. So that's chapter 3. The next chapter is chapter 4, where we introduce the Neo4j GraphQL library, which is going to show us how to build a GraphQL API backed by Neo4j without having to write a lot of boilerplates. We'll get a lot of database query generation functionality for us. So we'll go through some of the features in the library next time, which will be, I think I still have it up here.
On the 15th.
On the 15th, yeah,
yep.
Exactly.
So exactly in 2 weeks' time. Skipping next week due to GraphQL Galaxy. If you are now eager to get going, obviously there's another week extra time, so you can catch up with all of us and download the book, read through chapters 1 to 3, do the exercises with us and the recordings if you need some help or some pointers, and then you can join in 2 weeks time for chapter 4, when we talk about the GraphQL library and take it from there. So would be nice. Would be good to see you. Not so many questions today. Maybe for many people this was old news, I guess. So you are, I assumed, more or less all well versed in Neo4j. Otherwise, questions are always welcome. So if you are now watching this and think, oh man, I missed the live stream and I don't know this or that, go to our community page, go to the Discord server, go to Stack Overflow, other places, and you ask questions. Community and Discord particularly are easy ones to find a wide number of Neo4j folks around, as well as experts from our community who can help you with your questions. So don't be shy and dive in right there. The only other thing I have to say is next week, besides GraphQL Galaxy, so if you are looking for some other Neo4j content, we have on the 6th a Going Meta episode. It's already episode 11, I think, of Going Meta, where Jesus and I talk about semantic web, knowledge graphs, and other topics around the world of wider world of RDF and connected data here. So that's on the 6th. And on the 7th, Adam Cowley invites Jason Lengsdorf, famously known from Learn with Jason, to do a special episode of Learn with Neo4j, where they will do discuss and learn along each other, I guess, how to deploy Neo4j applications using Netlify. So that's on the Wednesday, 7th of December next week. I think that's pretty cool. 2 cool streams that are happening. So if you are interested, they are already on our page, so you can get notified. Subscribe to YouTube channel, obviously, for more information about this. And yeah, I'm looking forward to seeing you on either of these next week.
There's a lot going on next week. Scrolling through the events here, there's quite a bit happening. It looks like that's fun.
Yes, yeah, we are. I think until end of year busy with a couple of other sessions. So next 2 weeks, I would say, are still super active. Then it's going to be a little bit quieter. But then if you miss content, notes videos have been published or are about to be published publicly on YouTube as well. So if during Christmas and New Year's you are eager for some graph videos, you have 110, I think, videos to catch up from notes. So let me quickly find that link.
They're all so from the Neo4j YouTube channel. If we look, right here, there's a Nodes 2022 playlist.
Exactly, it's right there's a playlist right there.
No, how many did you say? 100? Oh wow,
100,
there's
it's 100 and what did you say? 111. Yeah.
Wow. That's a lot. It'll take us a while to get through. I feel like I've watched maybe a third of these live, and then plus a little bit. A lot to catch up on.
Yeah, exactly. Lots to catch up. And Yolande wrote a super good blog post. So if you go to neo4j.com/blog, and the first one you see highlighted there is on Notes 2022 talks you didn't want to miss, or you obviously didn't want to, you'd like to watch again. And there she highlighted 20 talks that we think are great, but also the users thought are great. So every talk had a little rating session afterwards. So the audience was invited to give thumbs up or thumbs down. So stars from 0 to 5. So similar to the little data set we just showed here. And they are all above 4.5, I think, per actual watchers rating. So you see pretty great sessions, various topics across all wide range of things. So I'm pretty sure there will be something for everybody in there. So if you look at its, have a look, watch some videos, and
That's nice. These are all embedded. I don't have to hunt around for them. I can
exactly these are
click right
directly
through.
there. Yeah, directly out of the blog, you can click on them to watch them. So yeah, super easy.
Cool, good stuff.
Yeah, good. I think that's it. I still see no other questions coming in on anything we said, so everything was clear, hopefully. And if not, then don't be shy to get in touch with us later. And yeah, with that, I think we're at the end. Thank you, Will, for chapter 3, obviously, and also for writing the book. So we will be back, as we said, in 2 weeks' time.
And hope to see some folks next week at the GraphQL Galaxy workshops.
Oh yeah, give Will a shout out if you're attending and if you watch his the video here. So that's always nice to see.
For sure.
Yep.
Thanks for joining, everyone. See you next time.
Everybody. Take care. Bye.